Hello everyone, welcome to Equal To, and this is the 7th video of the number systems playlist. If you haven't seen the previous 6 videos yet, please go and check them out. Only then you would be able to understand this video easily. Okay, now in the previous video, we ended with a technique to prove something is a rational number, right? I hope you remember that. That is the technique that we are going to use it in this video as well. It's the same technique that you are going to use it in this video, but a slight variation of that. Okay. Now, in the previous video, we stopped with this, where we proved 0.3 bar is in fact a rational number. Now, we are going to do the same thing, but just with a different number. Okay. Now, here we have a number 1.2727272727 and it goes on forever. So, it can also be represented in the form of 1.27 bar, right? 1.27 bar, where you have the line above 2 and 7, meaning that only those two numbers are going to keep on repeating. And you are going to express this in the form of P divided by Q, where Q is not equal to 0, right? Now, let us start with the same assumption that we started with in the previous question. Okay. Let x is equal to 1.272727. Okay, so this is the assumption that you are going to start with, and let me tell this is as equation 1. Okay, this is equation 1. Now, since there are two digits that are repeating, we have two digits, right? Two digits that are repeating. Those two digits are 2 and 7. These two digits are keeping on repeating. Now, since we have two digits, we are going to multiply with 100. Multiply by 100 on both sides of the equation. Okay. Now, in the previous question, only one digit was repeating, and so we multiplied by 10. Now, in this question, two digits are repeating, 2 and 7, both two digits are repeating, and you're going to multiply it by 100 because of that. Okay, so what would that give you? 100x is equal to 127.272727 and so on. Okay, this is the equation that we get. Now, you are going to use the same logic and you are going to replace some value on the RHS with x. Okay, you are going to replace some value on the right hand side with x. So, what will you do is that a simple technique is you take your current RHS 127.272727 and you subtract your x value from it. Okay, what is your x value? 1.272727, and this goes on forever. Now, on subtracting this, you would get 126. Am I right? You get 126. Now, that is how we are going to split this up. 100x is equal to 126 plus 1.272727. Sorry. Okay. Now, since we want to deliberately replace something in RHS with x, we have split it in such a way that you can easily replace that with x. Okay. Now, this portion is exactly the value of x that we assumed. This is not by accident, this is how we calculated here. We calculated and wanted that value here. Okay. So, that we have got. Now, what you are going to do is that you are going to replace this value with x. So, 100x is equal to 126 plus x, and that would become 99x is equal to 126. Now, in this place, what we have done here is that you have subtracted x on both sides. You have subtracted x from RHS as well as LHS. Okay. So, some of you might have learned that this x on going to the left hand side becomes negative x, and that is how you subtract. That thing is wrong. Okay, that is not how things happen. In an equation, you are subtracting both sides by x. Okay, subtracting x from 100x gives you 99x, subtracting x from x gives you 0x. So, 99x is equal to 126, and that tells you x is equal to 126 by 99. Okay, 126 by 99, and this is clearly of the form P by Q, where Q is not equal to 0. Okay, now this is your P, this is your Q, and Q is not equal to 0, and hence you have solved this question. Okay, 1.27 bar is expressed in the form of P by Q, where Q is not equal to 0. This is very similar to the question that we saw in a previous video. It's the same concept, it's very similar, but just you have used a different number to solve it, and the same logic applies. Okay, now the only thing that was quite different is the way you split it. Okay, that is why I told you how to do that. You take the value of x and subtract it from your RHS, and that would give you the number, and that would give you how to split it. Okay, I hope you understood this question. Now we are moving on to the next question here, which is also very similar to the question that we just saw, but slightly different. Okay, now we are supposed to prove that 0.235 to 235 okay. Now in this question the number repeating is 3 and 5. Okay, 2 is not repeating, only 3, 5 is repeating. Okay, we are going to just start with the same procedure. We are going to assume that x is equal to 0.2353535, so on, 35 goes on. Okay, this is your assumption first, so that would be your equation 1. Okay, now what would you do after that? You are going to find the number of digits that are repeating. Okay, you might have heard a noise, sorry for that, it's a quite noisy environment, please bear with me. Now here we have 2 digits that are repeating, right? 3 and 5, both these digits are repeating. Okay, now since 2 digits are repeating, since 2 digits repeating, you are going to multiply this equation by 100. You are going to multiply this equation, both are LHS and RHS, by 100. So what would you get? 100x is equal to 23.53535. This is the equation that you get. Now as we just saw in the previous example which we just solved, how would you split it? We just want to substitute x in this equation, right? So you are going to separate this value in such a way that you get x clearly separated. So how would you do that? 23.53535 minus 0.23535. Okay, so both these things they get cancelled out, and that would give you 3 and 23.3. Okay, just a basic subtraction. Now that is giving you 23.3. Now I am just going to rewrite this in the same way. 100x is equal to 23.3 plus 0.23535. Okay, now we have done this deliberately just to replace this value with x. Okay, now we want to replace this value with x, and that is how we exactly have split it. Now in the next line I am just going to replace it with x. 100x is equal to 23.3 plus x. Now subtracting x on both sides give you 99x is equal to 23.3. Now we still have a decimal place in your RHS. So what I am going to do is that I am just going to multiply this equation by 10 on both sides just to remove that decimal place. So that would give you 990x is equal to 233. That implies x is equal to 233 by 990. Okay, that is it. Now this is obviously of the form p divided by q, where p is 233, q is 990, and that is not equal to 0, and hence it is a rational number and can be expressed in the form p by q, where q not equal to 0. Now this is an example where it is non-terminating but repeating. Okay, I hope you understood this example. This is very similar to the previous one, and the methodology is what we have seen in the previous video. Okay, fine. Moving on to the next question. And what is the question? Let me just read it first. Find an irrational number between 1 by 7 and 2 by 7. Now, we know that 1 by 7 is a rational number. Let me just first convert it into decimal. Okay, so how do we convert it into decimal? 1 divided by 7. We have solved it already, but let me just get the value. 0, that would give you 1. 1. I'm just going to do it very quickly because you already know to do this. 7 times 4 is 28. You get a remainder 2. 7 times 2 is 14. You get a remainder 6. 7 times 8 is 56. You get a remainder 4. 0. 7 times 5 is 35. You get a remainder 5. 7 times 7 is 49. You get a remainder 1. 7 times 1 is 7. Okay, so this goes on. So what is your value? 0.142857 the whole bar, right? So this block keeps on repeating, 0.142857. Now this is the value of 1 by 7. Now how do we find the value of 2 by 7? You can either do the same process, you can do the entire division once again, but instead of that you can just multiply 1 by 7 by 2. You can take the value of 1 by 7 and if you multiply it by 2, you would get the value of 2 by 7. Okay, that is what you are going to do now. 0.142857 multiplied by 2. 7 times 2 is 14. We have a remainder 1. 5 times 2 is 10. And 10 plus 1 is 11 and another carry 1. 8 times 2 is 16. 16 plus 1 is 17. Another carry 1. 2 times 2 is 4. 4 plus 1 is 5. And 4 times 2 is 8. Sorry, that doesn't seem like an 8. 8 and 1 times 2 is 2. And we have a dot, and 0 times 2 is also 0. Okay, so we get a number 0.285714 and that would obviously come under bar, right? Okay, now this is the value of 2 by 7. Let me just clean this up. Okay, and I'll also move this. Okay, and this as well. Yeah, so this is 1 by 7. On the left you have 1 by 7, on the right you have 2 by 7. Okay, we have two values and these are non-terminating but repeating values and these are rational. So rational numbers, if they are non-terminating, they are in fact repeating. So with this definition, can you define irrational numbers? Irrational numbers, when expressed in decimal expansion, they are non-terminating and non-repeating. Okay, non-terminating and non-repeating. Non-terminating, non-repeating. You are just going to make use of the same definition and just going to add a word not. Okay, if it is terminated, it obviously is a rational number. If it is not terminated, we have two cases. It can either be repeating, in that case it is a rational number. It can be non-repeating, in that case it is an irrational number. Okay, so that is the definition for irrational numbers. Irrational numbers are numbers when expressed in decimal fashion, they are non-terminating and non-repeating. Okay, remember this definition. Now with this definition, you are going to generate a irrational number between this range. Okay, now it should be non-terminating and non-repeating, okay, and it should be in this value. So let me just 0.1, let us say have 5, okay, let the second digit be 5 and we can have random numbers 1 7 9 7 8 1 0 5 6, it can go on forever, okay. Now you might think this is a random number and he's just messing with you. I'm not messing with you, it's the right answer, and anything that you think of is the right answer provided it is in the range 0.142 to 0.285. If it is within the range and it is non-terminating, meaning it goes on forever, and it is non-repeating, there is no pattern here, 012 501 797 8105, there is no pattern here, the block is not repeating, so it is a non-repeating and non-terminating, and hence this number is a irrational number, okay. So this number is a irrational number. Now this might not seem like a proper way to answer this question to you, but believe me, this is the right way to answer this question, there is no other right way. So that is it for this question, and I hope you understood this. If you have any questions, if you have any doubts, please put them in the comments. I'll get back to you as soon as possible. These are quite simple things, I guess. So I hope you understood these things. Now, thank you so much for watching this video. See you in the next video. Bye for now.